Okay, so I'm going to go over number 4. Basically the same thing as number 3. But I'll go over a little bit quicker. So step 1 was I group the x values together, x squared minus 2x, and then I group the y values together, y squared plus 18y. And then remember, I have to do minus 33 on both sides, so it's going to be equal to negative 33. Okay, and then from there, I have to complete the square. I got to complete the square. So I'm taking this negative 2, and I have to divide that by 2. So it's negative 1. And then I have to take negative 1 squared, and that's going to be positive 1. So I'm going to take this positive 1, and I'm going to complete my square. Okay. So that positive 1 goes there, and then this is that negative 2. Okay. Now I'm going to do the same thing for the y. I know 18y is my coefficient. Sorry, 18 divided by 2, that's 9, and 9 squared, that's 81. So this time I'm going to add a bigger number, 81. 18, so 18y plus 81. Okay, plus 81. Okay, equals, whatever I do on one side, I got to do on the other side. Plus 1 plus 81. Cool. All right, let's simplify. Now step 3, I got to factor. So I got to turn all of this into x something squared plus y something squared. And then this part, let's do this first. Negative 33 plus 1 plus 81, that should be 49. If it's not a perfect square, you did something wrong here, right? If it's like 46 or 47 or 48 or whatever it is, right? Then it's not a perfect square. So 49, that means my radius is going to be 7 squared, because 7 squared is the same thing as 49. Here, what number do I put here? It's always going to be this common factor that we used to get the complete square, the square, right? So I'm going to do negative 1 here, right? Because that's the common factor we used. And I'm going to do positive 9 here. And then 7 is our radius. So remember, if this is a positive, you're going to start doing the opposite. So now the center point is 1 and negative 9. Because remember, you have to rewrite this as negative 9, because that's how it turns into a positive. And then my radius is 7. Okay? That's it. All right, let's try number 5. 5a, b, and 5a and b. Find the coordinates of the vertices of each figure after the given transformation and graph the image. Okay, we're rotating 90 degrees counterclockwise about the origin. So 90-degree rotation, it follows this rule. And then counterclockwise, it's got to end up somewhere here. Right, we're going counterclockwise. So it's going to end up in that direction. It's going to be negative y and x, like that. So for each of these points, I, j, k, h, I need to use this rule. Let's start with h. H is sitting at 5 and negative 2. So then my new point, h prime, my x is 5, and then my y is negative 2. Now I got to bring the y to the front and then add another negative to it. So negative 2, that's positive 2. X is just 5. It stays the same. Now when I graph this, it needs to be graphed as an x and y, right? The reason why we swap the numbers and flip it is just because we want to get the numbers where they should be and then now graph it the way it should be graphed. So it's going to be right here. Let me move some of those points. 2 and 5. 2 on the x, 5 on the y. This is h prime. All right, let's keep going. I is on 2 and 2. So I prime. Now it's going to be negative 2. I'm attaching a negative to my y. And then x stays the same. Negative 2 and 2 is right here. J is on 4 and 3. So j prime is negative 3. and then, and then the x is going to stay as positive 4. Negative 3, where is it? Negative 3, positive 4, right there. K is at 5 and 3. So I'm going to do the same thing, negative 3 and positive 5, so negative 3, positive 5 right there. So if I connect my dots, you should see the rotated figure, right? On the test, I'm looking for this as well. This is part of the grade. If you don't show me the coordinates, I'm not grading it. It's partial credit. Okay, let's do the next one. Reflection. Reflect across the x-axis. So we haven't done this too much. We've mainly focused on the rotation. But reflection just means that if we're reflecting across the x-axis, that means you make the y opposite, like negative. Well, not make it negative, but it's the opposite version of it. So let's do this again, right? This is the rule for reflection across the x-axis. I'm going to start with k. K is sitting at negative 5 and 0. Sorry, negative 4 and 0. Okay. And so K prime, negative 4, the x doesn't change. And in the y, you have to attach a negative, but negative 0 is the same thing as 0, so it stays there. L is at 0 and 2. So L prime, the x stays the same. It's going to stay at 0, but then the y turns negative. 0, negative 2 is right there. M is at negative 2 and negative 3. So M prime, it stays at negative 2, and then it's negative 3, so negative 3 is positive. So negative 2, positive 3 is going to be all the way up here. And then J. J is at negative 3 and negative 3. So J prime, x stays the same, y turns positive, negative 3, positive 3. So when I connect my dots, it kind of overlaps, but that's okay. That should be my reflection across the x-axis. Okay, let's keep going. Figure number 6. Still on the coordinate stuff. Figure FGHI is graphed. FGHI is graphed. Transform that figure using this rule. X from x to y. XY goes to negative x and y minus 4. Graph the image, show your work. All right, let's do it. So this is the rule. XY to negative x and y minus 4. I have these points. Let's start with F. F is at negative 4 and 1. Okay. So my new point, it looks like x is my negative 4. And what I'm going to do is I'm going to attach another negative. So negative 4, that's positive 4. Y is 1. What am I doing to each of my y coordinates? I'm doing 1 minus 4, negative 3. So 4, negative 3 is right here. Okay. FG is at negative 4 and 4. So again, the x, it went from x to negative x. So I'm attaching another negative here. So that's going to be positive 4. And then my y is 4. 4 minus 4, that's 0. 4 zeros right there. H is negative 3 and 4 this time. Negative 3 and 4. So what is my H coordinate going to look like? It's going to turn into positive 3, and then 4 minus 4 is 0 again. So positive 3, 0. That's my H. And then last but not least, I is negative 1 and 3. And then I prime is going to be negative 1. That's positive. 3 minus 4, that's negative 1. So positive 1, negative 1. Okay, it's my I prime. So if I connect my dots, I see that shape. Describe the transformation precisely. If you look at the graph, you can kind of tell what kind of transformations took place. All right, but you might not know the specific, like it says describe it precisely. So if you want to be able to describe it a little more precisely, you have to look at the rule. We went from x, y to negative x and y minus 4. We know that like the placements didn't switch. Like we didn't put y here and we didn't put x here, right? So there's no rotation. Usually when there's a rotation, they flip the coordinates. We flip the coordinates. But I noticed there's a negative on the x, right? So when I look at my graph, the negative on the x, what did that do? I kind of just flipped it. It looks like it went from this side to the other side, right? So that's a reflection, right? If I went from that side to the other side, it's reflecting across the y-axis. And if I look at the rule, the reflection across y-axis rule, it goes from xy to, it actually goes from the xy to negative x and y. So yeah, that part of the x turning negative, that's the reflection part, okay? So I'm going to say that it's a reflection across y-axis. And then after that, what do you think this y minus 4 part represents? So we reflected it here. And then what's the y minus 4? And it kind of slides down 4 units, right? So that part is a translation, translating. How many units down? Down 4 units. Okay, that's the y minus 4 part, and then the negative x part is this, okay? So you need to be able to look at the rule and decide based on that rule what kind of transformation we have. And that's what you need to remember. So we did a reflection, we did a translation. Does the transformation result in a figure that is congruent to the original, similar to the original, both, or neither? So remember, similar shapes are two shapes that are the same but different sizes, right? So if I have like a rectangle like this, and I have a smaller rectangle like that, they're the same rectangle. It's just different size. One's bigger, one's smaller. That's similar. If they're exactly the same, no matter what, like no matter how you turn it around, right? Or flip it or rotate it, if they're all in the same area, the same perimeters, then that's congruent. So here I want you to think, are these two similar, congruent, both, or neither? It's got to be congruent, right? They are congruent because all we did was just flip it and then move it down, translate and reflect. And we also know that translation, so figures are congruent because we know that reflections and translations are rigid motions, right? Rigid motions. We said that rigid motions keep the shape the same, right? It doesn't change at all, okay? It's exactly the same. 7, 8, 9, 10. Dang, a lot of questions in here. Okay, let's keep going.